Good morning, good afternoon. My name is Matthias Damm from Unified Automation. As the editor of OPC UA Part 4 services, Part 14 pops up, and a member of the Technical Control Board, I would like to provide you with a technical update for the OPC UA Working Group. My presentation includes information about the changes in the OPC UA release process and new and upcoming features and enhancements. The current release is 105.02, and we are close to publishing 105.03 for review by OPC Foundation members. There are also new subgroups of the OPC UA Working Group, mainly to provide an environment where IT experts can discuss enhancements for IT use cases. There are also other activities to support users of OPC UA and companion working groups. The Harmonization Working Group is an important part of the ongoing improvement of the OPC UA platform. The release cycle between major releases has always been 3 years. This was not intentional. Whatever we did and whatever our priorities were, it took us always 3 years to make a new release. Since 102, we have provided erratas between releases to resolve issues, but with the growing number of working groups building on top of the core OPC UA specifications, the number of feature enhancements requests has grown. Many companion working groups complete initial specification releases in 1 year, and they cannot wait 2 or 3 years for enhancements in OPC UA. With 104, we added specification amendments for feature releases between major specification releases. This helped us to support the companion working groups. With the 105 release, we have consolidated all feature amendments and split the Part 5 appendix chapters into separate parts. This was the starting point for a continuous update, which is also the basis for the online reference of the OPC UA specification. In this new release process, the OPC UA Working Group will maintain only one version for each part in the future. Clarifications, errata, and feature enhancements will be released in minor releases such as 105.01 and 105.02. This will allow for shorter release cycles. The current version is 105.02, and the release cycles are now between 6 months and a year. Not all parts are updated in each cycle, only the parts that have pending changes or new features. The working group is currently finalizing version 105.03. Release candidate status is expected in July of this year. The release requires a 90-day member review period, which will start after the publication of the release candidate. With 105.03, all parts will have a 105 version, including Part 11 historical access, which will be the last to be updated to 105. The main enhancements in OPC UA 105 are the new release model and the splitting of the Part 5 appendix chapters into separate parts for Part 16 state machines, Part 18 role-based security, and Part 20 file transfer. For Part 14 pops up, we have added many enhancements for OPC UAFX requirements and quality of service parameters. The main feature enhancement was a way to apply configuration changes in one atomic step. In 105.01, the new Part 22 for base network model and Part 23 for common reference types have been added. The base network model allows the representation of network interfaces and TSN streams in the OPC UA server address space. The 105.02 release includes many security enhancements with clarifications and detailed workflow definitions for Part 12, certificate management, and the new secure provisioning, device provisioning, Part 21. This new part defines device identification using device manufacturer certificates. Based on the device certificate, a secure device onboarding workflow is used to obtain the initial OPC UA operator certificate for the device using the Part 12 certificate manager functionality. Calendar and scheduler objects are defined by the new Part 24. Most enhancements and additions are driven by the harmonization Working Group and companion working groups and the FLC Working Group. Subgroups of the OPC UA Working Group are used to get subject matter experts to prepare input to the UA Working Group. Such experts are typically not interested, do not have the time to participate in all the different detailed discussions in the OPC UA Working Group. However, enough experts in a certain domain or for a certain use case are needed to have enough experience to develop stable definitions for these topics. The Security Working Group subgroup analyzes OPC UA related security incidents and discusses new security features for OPC UA. The majority of the members of the OPC UA and FLC working groups are from automation system vendors, so we have more OT than IT experts in these core working groups. To ensure that OPC UA addresses the needs of IT, the new MQTT and REST subgroups have been initiated. The high level of interest in these working groups is helping us to have dedicated use cases discussions with IT experts. The base network model is working on part 22 for the representation of network components and configurations like TSN streams. Semantic validation is working on evaluation of semantic rules for validation of specifications, especially companion information models and query functionality. We have also subgroups that we already that are currently inactive or discontinued. One is TSN, where the work is continued in the base network model working group, the FLC networking subgroup, and also the part 14 extension to POP-sub if needed for TSN. Also, the POP-sub prototyping is inactive since part 14 is released and implemented in products. The POP-sub MQTT transport protocol mapping and also the JSON message mapping were part of the first release of POP-sub in 104. Nevertheless, the prototyping and use case discussions, especially with experts from the FLC and OPC UFX working groups, were very OT-centric, and most of the detailed enhancements were mainly in the device-device controller-controller communication with UADP message mapping and UDP and Ethernet transports. So we wanted to make sure that also the IT use cases with MQTT and JSON message mapping get a similar level of discussions and enhancements that we had already with the other combinations. So we started the MQTT subgroup to get more IT experts to discuss IT messaging with MQTT and JSON. There is a lot of interest, and we have typically between 20 and 30 people in the bi-weekly working group meetings. And we have already first results. So we have features that we already included in the 105.03 release of part 14. One is JSON header layouts, which defines header settings for different use cases, is something we have also already for UADP. This makes the configuration easier depending on the use cases. And the second addition is a MQTT topic tree definition to standardize the default topic tree for data events, but also for metadata discovery. The upcoming and current work items where we continue the work for the next part 14 release is a feature to provide commands through POP-sub messaging, to provide OPC address space information in the MQTT topic tree, and also optimizations for dataset metadata. Security is a core feature of OPC UA at several levels and will be discussed in different presentations this week. The basic security level is application authentication. Each application, regardless of its role as client, server, publisher, or subscriber, is identified with a X509 certificate. OPC UA defines user authentication with different types of user tokens and user authorization with role-based security, and the ability to set permissions down to node attributes such as read or write access to a variable value. This also requires centralized management services as defined in OPC UA Part 12. These include application discovery, certificate management for applications and users, central user verification and central role assignment, or management of credentials such as passwords for access to MQTT brokers. Other features such as POP-sub security key distribution or alias name also benefit from centralized services. But it all starts with certificate management for applications. And centralized management is becoming more important with the adoption of secure OPC UA communication within OT networks, not just between OT and IT networks. This is also being driven by the adoption of OPC UA at the device level with initiatives such as OPC UA field level communications. This is therefore a priority for the OPC Foundation in interoperability testing events, certification, trade show demonstrations, and specification enhancements. Clarifications and more detailed workflow definitions for the certificate manager and the new Part 21 for secure device onboarding were highlights of the recent 105.02 release. A large number of OPC UA applications support integration with the GDS certificate manager using both pull and push models. In the pull model, clients can request an initial certificate or update to the certificates and trust list from a central GDS certificate manager. In the push model, the certificate manager can push initial certificates or updates to OPC UA servers. The number of GDS products implementing the centralized services is also growing. These products are either standalone GDS products or part or extensions of existing products that add certificate rollout capabilities based on OPC UA Part 12 Certificate Manager interface definitions. One of the first products is the Amazon PAC Security Center, originally released in 2015 as part of GE's Intelligent platform. A standalone GDS is available from Unified Automation. This UA GDS product is also available as a partner application on Siemens Industrial Edge. Rockwell Automation has also announced the addition of GDS Certificate Manager support to FactoryTalk Policy Manager. For operators, ask your OPC product vendors to support integration with the GDS Certificate Manager pull or push. For product vendors, make sure your product supports GDS Certificate Manager integration, otherwise your customer will help you to prioritize the support in the future. OPC UA for devices is a base specification that is used by a lot of companion working groups. They use it mainly for asset management device identification. The initial versions of OPC UA for devices were mainly around device management, device configuration, device identification, but also a network model, network communication model. And the main uses were FDI and FTT mappings to OPC UA. In version 103, we added firmware update, parameter backup, restore, software management functionality that is also needed in the OPC UAFX specifications. In 104, we added operation counters and lifetime models. That was a request by companion working groups that needed a home for these base definitions. Currently, we have, again, discussions about enhancements for new use cases for the software management, also coming from the OPC UAFX working groups. The key thing is to complete a secure device deployment, device lifecycle from Part 21 with the manufacturer device certificate to installing the device, updating software after identifying the device from the vendor, and then applying the operator certificates for secure operation. The OPC UA Working Group develops OPC UA specifications that are the base for information model specifications developed by companion working groups. The Harmonization Working Group was started by the OPC Foundation to support companion working groups and to make sure that we avoid double definitions in different working groups. So the members of the Harmonization Working Group are from the companion working groups, but also OPC UA experts from the OPC UA Working Group. The tasks of the Harmonization Working Group is to identify common features and feature requests from different working groups, to review companion specifications, to identify duplicates of features, or to support them with questions for information modeling or with best practice from other working groups. The Harmonization Working Group also manages templates for the companion specifications. The Harmonization Working Group is also handing over requirements to the OPC UA Working Group for core specification enhancements for these common features, but also develops own specifications that can be reused by different companion working groups. There are different results specifications that are initiated and supported or maintained by the Harmonization Working Group. First of all, additions to OPC UA 105 core specification, like the base network model, which is now our own subgroup of the UA Working Group, but also Part 23 common reference types and Part 24 scheduler were developed by the Harmonization Working Group and are now handed over to the UA Working Group. Additional OPC UA specifications that are still released and maintained by the Harmonization Working Group are 110 asset management basics, 120 XML data type mapping, 200 industrial automation model, and 210 relative special locations for local and global coordinates. There are also some supporting documents like specification templates, specification guidelines, and best practice documents. To summarize my presentation, OPC UA provides a stable and established IoT platform as base for many information model working groups. Core features like services, address space, information modeling capabilities, and security features are unchanged since more than 10 years. Nevertheless, if needed, we also add basic features like pop-sub communication or safety, both added in OPC UA 104. But main enhancements are on information model level and are a continuous improvement based on feedback and input from companion information model working groups. Another important aspect and an always ongoing process is the improvement for security and for secure device lifecycle and software lifecycle. Thank you for listening to my presentation and enjoy the rest of the week with a lot of very interesting presentation. Thank you.